Hello, everyone, and welcome to our next session on the Python plus Agent series. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for your questions. I'll now turn it over for our speaker for today. Thank you and welcome, Pamela.
Hello, everyone. Welcome to our Python plus Agents live stream series. This is session 3 in the 6-part series. So we are at the end of week 1, which is all about building agents with Microsoft Agent Framework. Week 2 will be all about building multi-agent workflows with Microsoft Agent Framework. If you did miss any of the previous sessions, you can catch up with recordings and write-ups and slides by visiting our resources link, which I've shared in the chat. And if you're not registered yet, do register for the series, because then you'll get notified when the next session is starting and you'll get emails with all the resources. So let's get into today's session. We are talking about monitoring and evaluating agents. These are really important things that you're going to want to put in place when you're building agents for production. So we're going to talk about monitoring, which means using OpenTelemetry to be able to actually watch and see what the heck is our agent doing, and then exporting that to our favorite OpenTelemetry platforms like Aspire or App Insights or any other ones. Then we're going to talk about evaluation, which is making sure that your agent is actually producing high quality outputs, right? It's very easy to make agents these days. It's harder to make high quality agents. So how can we actually do that? We've got a great SDK that has lots of evaluators specifically for agents. And then finally, we're going to talk about safety, ensuring that your agent is not going off the rails and is adhering to good guardrails and isn't going to, succumb to the trolls on the internet. If you do want to follow along with the code, all of the code is in this GitHub repo, the same repo we've been using throughout the series. If you've already got it checked out, you might want to do a git pull on your local copy, because we often make little changes each day as we're testing stuff out. But if you haven't checked it out yet, you go to the repo, and then I recommend clicking on the code button. And here you're going to see a button that says create code space on main. So you click that button and that will create a code space, which is a VS Code running in the browser. And you just give it a few minutes to run while I'm talking. And then when you get back to it, you will see that the code space is all set up. It's got the Python and the Python dependencies and all the examples there, so that then you can see the code and run the code. Now, normally we make it so that you can run all the examples in our sessions, but in this session, we are using a few more resources that aren't going to run for free. Typically, we're just using LLMs, and that we can use for free from GitHub models. But today, we are going to integrate with a few other Azure resources. So unfortunately, you can't run all the examples for free in Codespaces Day, and I'll let you know as we go along. But you can still follow along with all the code here. It's all available, and you can set it up to run with your own Azure resources as well later to try stuff out. So there you go. There's the repo. Go ahead and get that set up if you want to follow along with the code. Now, just as a brief recap, just talking about what is an agent. This is week 1. It's all about agents. So I'm going to keep hammering home that an agent is something that uses an LLM in order to achieve a goal, and it uses tools with in order to achieve that goal, right? So we say, hey, agent, here's our input. Here are the tools that you have at your disposal to answer this input, answer this user's question, to, do this task that it's assigned you to. And the LLM is going to decide which of those tools, and it's going to keep calling tools in a loop until it feels like it has enough information and enough capability to achieve the goal, right? And sometimes these cycles will be very quick, like it gets the input, it doesn't need to call any tools, and there's the output. And sometimes it might rank like 20 tool calls in order to, achieve the goal, right? So that's what's interesting about agents is they're non-deterministic. They can be very short runs, they can be very long runs, and they can really, really vary in what tools they choose to call, how they choose to get to a goal state, right? So when we're making these agents, we really need to have monitoring so we can see what is the agent actually doing? How did it get to that goal state, right? What tool calls did it make along the way? Did it do any? Did it do the right ones, right? And then along with that, we need evaluation so that we can say, okay, like, the agent did these things. Is that what we wanted it to do, right? Like, did it call the right tools? Did it get the right output, right? So you really want these two things in conjunction, right? So that when you put an agent into production, you can have confidence that you're able to see what the agents do. And if they aren't doing a good job, you can improve your evaluations and, improve your models and your tools so that you're seeing better results. So these two really do go together with each other. And that's why we're talking about them. So first, we're going to talk about how to monitor agents. This is also known as observability, right? We talk about this all the time when we're building any sort of applications, like for user-facing applications. You need observability. You want to know what is going on. So it's the same thing with agents, and even more important for agents because there is so much non-determinism to what they do. There is so much choice that they give them. They have so much agency, right? That's the whole thing. We've given them the agency to decide what tools they're going to call, but we want to observe and see what is it that they actually chose to do. So we are going to do observability using this open standard called OpenTelemetry. This is what we generally recommend when you're setting up observability for any sort of application, is to use this OpenTelemetry standard. It is the most well-supported standard for observability across the entire industry. It's supported by many different logging platforms. So if you use OpenTelemetry, then you're going to be able to use many different tools in order to look at your logs, right? So it is a standard that says this is how applications should emit traces, and traces basically show what happened in the app, like some event that happened. Metrics, which is like kind of numbers, like, hey, you're using this much CPU and you have, this much latency, and then you can make graphs based on those metrics. And then just logs, right? Every time we do like a logger.info and logging.info in our app, we want a structured way of sending those logs in our observability platform, right? So we're going to use OpenTelemetry for the traces, the metrics, and the logs so that we can see exactly what our agent is doing, set up dashboards, set up graphs, and really be able to observe everything. Now, Agent Framework, that's what we're using to build our agents. Agent Framework has built-in support for generating OpenTelemetry traces. All we need to do is import this configure OTel providers, right? So this is a function that we import from Agent Framework. So we say configure OTel providers, and you decide whether you want to enable sensitive data. And that's stuff like the tool calls, right? There's a lot of things like you do want to think about when you're logging stuff, whether you might accidentally be, like, are you logging things that's potentially private information, right? And that's always just a, kind of trade-offs and benefits, right? Like, if you're going to log tool calls, there might be some private information there, but also you'll be able to better improve your system. You could also consider adding some middleware that will like strip out that private information when you send it to. So it's just a decision you're going to make and think carefully about what is the data that we are logging, and are we comfortable with having that data in our observability platform, right? Generally, the more data you have, the better you can improve your systems, but you certainly, don't want to be, violating, any sort of user privacy, right? So I have that example here. Agent OTel Aspire is the first example. So it's saying we, import this configure OTel providers, and we can decide whether we're going to enable sensitive data. And, and here I decided to set it. And there's many ways you can customize this function here. So you can look at all the arguments. But generally what it's going to do is look at environment variables, because there's with the OpenTelemetry, there's all these standard environment variables. So you can see it lists a bunch of them here. There's quite a bit more as well. So it's going to look at those environment variables to figure out how to configure itself, right? So let me just show you this example without any of the OTel, just so you can see what this example is doing. And then we can look and see what the actual OTel logs look like. See, there's a question, doesn't OTel add latency? That's a good question, right? So when we're generating traces, we're often going to be sending those traces somewhere. So that, and that we call exporting. So you can see here when you're configuring this, you can specify exporters. A lot of this is about the exporter. So generally you're going to be exporting your data because you want to be able to surface it in your favorite observability platform. And so that can add a certain level of latency because that is a network request. It's usually a very fast one, like faster than anything else, because it's just straight sending it to that platform. And those observability platforms are generally designed to be, be able to process things really quickly. But that is something you can think about. A lot of times you can set like your sampling rate. So maybe you don't want to send all of your traces. Maybe you're only going to send like, especially if you got like millions of users, right? You could set a sampling rate that says like, oh, only send like 5% or 1%, right? So that way you do get to see roughly what's going on, but only for a percentage of your users, right? And so that would be, one consideration. But generally, yes, exporting will take some amount of time, but it's low compared to other things we're doing. All right, so this is just a really basic weather agent, right? It makes looks like two tool calls, getting weather and getting current time, and then returns back an answer. Okay, so the first thing I'm going to show is just what the OTel traces look like in the logs. Just locally without using an exporter. So we can say enable console exporters equals true. So I'm just going to set this environment variable and then rerun the example, right? So I'm just setting it here and then saying UV run, right? So it means when UV runs this, it's going to run it with this thing true. So this is a console exporter. So this isn't sending off to any sort of separate observability service. This is just going to show it in our direct console just to see what traces are being generated. All right, so what we see is a bunch of spans. So within a trace is a bunch of spans. So within each trace is a bunch of spans that are basically the children of that trace. And so here we have a bunch of spans. So there's like a span for executing a tool. There's a span for executing the other tool, the get weather tool. There's a span for making a call to the chat completion model. This span is pretty big here. And this is a span for, oh, and these are metrics, right? So we also see metrics, and this is a metric for token usage. Now, obviously, this is not a nice way to view our observability data. Like, no one wants to sit here and look at a bunch of JSON for spams, right? So the first thing you are going to do is decide where are you going to export your OpenTelemetry data so that you have a nice way of viewing it, right? So nobody wants to look at all this, right? That's not fun. So let's talk about exporters. There are many OpenTelemetry compliant observability platforms, and some of them are some of them are open source, some of them are managed, some of them are both open source and managed. So here I just have a brief subset of observability platforms. So today we're going to be using Aspire, which is an open source platform that you can use locally. It does not have a managed version. We're also going to use Azure Application Insights, which is not open source, but is managed. And that's what many people use when they're deploying to Azure. So we are going to see this today as well, because these are both from Microsoft, and we can set both of them up at the same time. These are some other ones you may have used: Datadog, Grafana. There's actually support for Grafana like within App Insights now, which is interesting. Prometheus, Jaeger, Logfire. I really like Logfire. That's from the creators of Pedantic, and that has a really nice UI, and it is all OpenTelemetry compliant and easy to export to. So yeah, so that's just some of the observability platforms. If you have another favorite one, go and put that in the chat, and talk about your favorite way to view observability data. So let's first look at how to export to the Aspire dashboard. So to do this, you need to set this OpenTelemetry environment variable. So OTel exporter OTLP endpoint. And then you set it equal to wherever your Aspire endpoint is. So your Aspire is basically like a server running, running locally. So we're going to use this for local observability. So it is running locally and showing your OpenTelemetry logs. So that's really the only environment variable we have to set. This gRPC is actually the default, the protocol. We did have to also install this exporter, however, so you will see that in the pyproject.toml. You'll notice that we do have this here, OpenTelemetry exporter OTLP proto gRPC. So we did need this in order to be able to export to Aspire. So that is already installed in the environment when you open this repo. And then we just call that function like we did before. That function is just looking for these environment variables. And in fact, I actually already have them set in this environment. I could echo it out, echo OTel exporter OTLP endpoint. Okay. And yeah, you can see it's set. And in this case, it's set to, this is inside a dev container. So it's set to the Aspire that's running inside the dev container. So if you are opening it in GitHub code spaces, we've actually set up Aspire in the dev container. You can see it here inside the Docker Compose. So this is how we set up the dev container. So it has multiple services running. So it does have Aspire dashboard running based off of this Docker image and on this port here. And so that's why I've set the endpoint to Aspire dashboard and to the exposed port. And this actually became, this is we can see it here in our ports. So that should already be set up. If you're running inside GitHub code spaces or the dev container, that should already work. I'll actually do it inside the code space so you can see. So I'm going to open that same file as before and say uv run examples agent otel aspire.py. And I don't actually need to set any environment variables because they are already set up inside this environment. So now I'm going to open that Aspire port. So if you go to the ports tab, you should see various ports. First one's Postgres, this one's Redis, and this one here is Aspire, the one that's like 18888, right? So that launches this Aspire dashboard here. And so we should see, let's go ahead. All right, so here we go. So in traces, we can see these traces going by. And so I can see, so 1048, that's one I just did. So this is a trace and it has 5 spans inside of it. So I can click on this 5 spans. And the cool thing here is you can see like the total duration. So we can see the total duration was 3 seconds. And it started off with an initial call to GPT-4.1 mini. And that one, came back with a decision about what tools to call. And so then it called get weather, it called get current time, and then it sent the tool call results to GPT-4.1 mini again. So this is really helpful because we can see, first of all, it's very clear that the thing that takes up a lot of time is those LLM calls, right? Like the tool calls are like that, right? At least in this case, because we're not using an API. In the real world, we would have get weather call an API. And so then we would see the span for that API call as well. But you can see that our LLM calls definitely take a good amount of time. And this is what you're always going to see when you're looking at the traces for LLM-based applications is those LLM calls are taking up so much time, right? Now we can also, if we click on, there's a little sparkle here. So the sparkle brings up a prettier agent-oriented way of viewing it. So you can actually see the full log here. So we can see, okay, you're a helpful assistant. What's the weather in Seattle? And then the output says get weather and get current time. And then the assistant responds with this, right? So we can kind of view the whole conversation. So Aspire is trying to render this, in a more developer-friendly way, because it realizes that this is a LLM conversation, and so it has an idea of how it's going to render it. But we can also look and see all the stuff that got sent to, to the dashboard here. Let me click on this one as well, right? So let's see. All right, so this is actually really interesting. The response from, we talked about parallel tool calling the other day. We actually see that the LLM responded and suggested 2 tools to call. So it said call get weather and call get current time. So this is something that some LLMs support, is the ability to specify 2 tool calls in a single message. And then the agent framework decides, how it's going to call those tools, right? But we can immediately see like, oh, okay, the LLM did actually decide to, within the same request, that it's going to call both those tools, which is nice because that means we saved on an LLM call, right? Other LLMs, if they don't support this ability to specify 2 tool calls, they would have had to make another call in order to say like, okay, great, you called get weather, now call get current time. So we can immediately start to get more insight into how the LLM is actually processing this information, right? So there we go. So this is with Aspire. We also have logs, but it looks like I didn't send any logs to it. There's also metrics. So saying you can do token usage. So here, it's not going to be very exciting because I haven't sent a lot of requests out there, but it will, monitor your token usage and your duration. Let me change this to last hour. Okay, great. So here we go. So now if we look at token usage, we can start to see, right? So you can imagine once you have like a good amount of data, you'll get a much better feel for, the peaks and valleys and averages of how much tokens are being used, used by these calls, right? Same thing with duration and function invocation duration as well. How fast are your function calls? In this case, my function calls are very fast because they're all, they're not making any network calls themselves, but you may have some much slower function calls as well. So the metrics is really helpful too. All right, so this is Aspire. So this is a good option if you want to make sure that your OpenTelemetry logs and traces, that they're all set up correctly, and so that so you get insight into what's happening when you're developing locally. This is only really for local development right now. Once you move into production, you're going to want to send these to an actual platform that is managed on a website, so that you can log in, your colleagues can log in, and you can all see what is going on. So that brings us to another platform. So Azure App Insights. So in order to use Azure App Insights, we do need another package, which is in our pyproject.toml. So here, pyproject.toml, we can see Azure Monitor OpenTelemetry. That's going to help us set up the Azure Monitor exporter. So we bring in that package, and then we have in another file, agent OTel app insights. We have this set up. All right, so we import a few more things in order to set up the exporting from agent framework. We also import configure Azure Monitor from that Azure Monitor OpenTelemetry package. And then we load in our environment variables because in our .env, I'll show you in my .env, I do have an app insights connection string. So I set that up and say configure Azure Monitor using this connection string, using this resource from the agent framework, and enable live metrics, right? And then I'm calling enable instrumentation from agent framework. And this is similar to the call we made before. And that will set up the app Insights exporter, right? So now whenever Agent Framework generates OpenTelemetry traces, they will get exported to App Insights. All right, so let's go ahead and try this out. And this one I'm going to run locally because that's where I've got my App Insights environment variable set up. And this is one that, isn't going to work in the code space unless you also set up an App Insights on Azure and set this environment variable here. Which you can do if you do have an App Insights set up for testing that you want to try this out with. So now we're running the agent. And the first thing it's going to do is set up that App Insights connection string and set up that exporter here. And we're just going to wait for that. Let's see what question. All right. Okay. So now we can see App Insights export is enabled. Great. Now it's actually running the agent. It's making some tool calls. And it's going to respond based off of those tool calls. Great. All right, so we've run it. So now that it, sends the trace to App Insights. Sometimes there is a little bit of a lag, like maybe 5 minutes lag between something happening and it showing up in App Insights. I did also run it earlier this morning, so we should have some data we can see. So what I do is here is my App Insights in Azure. And, you see not much data because I'm just running demos here. But we can go to I always go to the performance tab. I find this is the easiest way of finding local recent things that happens. So I click on dependencies and I'm just going to find one of these. And these are basically all spans. So I just click on any one of these spans and it brings me to the full trace. So here is a full trace. And what we can see in this trace, this does look really similar to Aspire, right? It's a very, like the pattern is the same, right? Here's the overall call of invoking the agent. And then within that invoke agent parent span, we have the span for making the chat completion call. Then we have the 2 tool call spans. And then we have the final chat completion call, right? And we can look at any of these. And once again, you see that the App Insights also manages to render this as something more friendly than JSON. I saw a comment that some people enjoy reading JSON, but I think you'll find that it's a little nicer to, view it like the in this kind of conversational way. Now, what's interesting that I wanted to point out is that within all of these spans, each span has what's called attributes. And we have this standard. So the standard is gen_AI. And so you'll see all of these traces, the attribute names or property names start with gen_AI. This is a OpenTelemetry standard for Gen AI based applications. And that is the only reason why App Insights and Aspire were both able to render these in a pretty way, because this is a standard. So it's not that they know anything about Agent Framework. It's that they see, oh, you're using the standard Gen AI traces. I understand that this is a Gen AI conversation, and now I can render it a certain way. So it's really important that we're not just using OpenTelemetry, but we are adhering to this OpenTelemetry Gen AI standard, because then we can get these like nicer renderings, right? So here, these are, some examples of the Gen AI attribute names, right? So the operation name, tool name, etc. If you see gen_AI in front, that means it's part of this standard, right? So whatever we're exporting from AI agents, any LLM-based applications, we do want to be exporting our OpenTelemetry traces using this standard here. All right, so what you can do, this is gonna, and we view the traces here, and once you've got it set up in App Insights, then you might want to set up dashboards in App Insights. You might want to set up alerts. Like you can do all kinds of things. Once you make sure you're sending all the information that you care about to App Insights, you can then set up everything, right? Okay, so that was monitoring. So let's just see some, questions here, right? So there's questions like, is the library setting up the metrics? So Agent Framework is doing quite a lot of work for you if you're using Agent Framework. You can see here's the documentation about Agent Framework observability. I'll go ahead and put it here. I think they talk about spans and metrics. Yeah, so this, you can see these are the spans that Agent Framework outputs. They do invoke agent, chat, and execute tool. And then these are the metrics that they output, which is the operation duration, the token usage, and the invocation direction. Now, you can always set up additional stuff, right? OpenTelemetry is very customizable, so you could set up other metrics that matter to you. You can also bring in other instrumentations, right? Like when I'm doing a fast API app, I'm going to instrument all the requests and responses. If I use using the Azure Python SDK, I'm going to make sure I've instrumented all the Azure Python SDK calls, right? So whatever package you're using, there's often a way to make sure that that package, especially if that package is doing network requests, there's usually a way to make that package export spans, right? So Agent Framework is going to take care of exporting these spans and these metrics. But if you're using any sort of other frameworks or SDKs, then you want to, make sure you're also exporting spans from that one. And if you need anything more, you should be able to set up your own custom spans and metrics as well. Okay, all right, so now let's keep going. Remember, we do have office hours afterwards where we can talk about any additional questions. So now we're going to talk about evaluating agents, right? Making sure that the agents are doing a great job. And I'll link to the docs around this as well for you to reference later. So as I've said many times, when we're using LLMs, we are using non-deterministic systems, right? And every time we have another call to an LLM, that increases the non-determinism of our system, which increases risk, right? So we have less control over the output, right? And for those of us that are control freaks, that's rather unnerving. But we're also using this fairly powerful tools that can do a lot of work for us. So it can be worth it to build applications based on LLMs if we can build the confidence in those LLMs that they are doing a great job. And when it comes to an agent, that means that the LLM needs to be choosing the right tools, choosing the right order for the tools, choosing the right arguments when it calls each of those tools. And then finally, when it comes up with a response, that it's creating a response that is grounded in all of those tool call results, right? That it hasn't missed any information and it hasn't made up any information. So we want to ensure, a high quality final result. And that usually depends on the LLM doing a good job picking the tools along the way. And the thing is, anytime you change something about your system, if you change your model, even from GPT 5.1 to GPT 5.2, if you change a temperature, if you change your prompt, then that can affect the quality of your model. And you really want to have a way of ensuring that you don't have a regression in the quality of your agent. So you want a rigorous way to evaluate and say, hey, I changed this one part of our system. Is that actually a good change, right? Some people do it just based on vibes. You can certainly make a change based on vibes, but then you should verify that by using rigorous evaluation, right? So how can we actually do evaluation? One approach is that you can do human grading if you do have a team of humans with domain expertise that is able to look through a bunch of responses and they can thumbs up and thumbs down. And then you can see, oh, okay, well, we got like 90% thumbs up, 10% thumbs down on this run. And then, we got 80%, thumbs up on the next run. Okay, so it looks like this first one's better. So it is definitely helpful if you have humans with expertise to be looking through data sets. Generally, there's only so many they can look through because they're humans with, limited time. But they can be particularly helpful for annotating issues and saying, not only is this wrong, but this is the reason it's wrong. So it is very, very helpful and recommended that you do have humans evaluate outputs and tell you why something's wrong, because then you can decide what sort of automated evaluations you need to set up to ensure that you don't make that exact mistake, right? So ideally, you always have some form of human evaluation that those humans have domain expertise and they won't be persuaded by, an LLM's hallucination, right? Because remember, the LLMs, they can be very convincing when they're wrong. So you really need to have somebody who has expertise in that domain who can say, yeah, that sounds right, but it's actually wrong, right? So then you want to set up automated evaluation. And the advantage of automated evaluation is that once you have it set up, if it's really measuring quality well, then you can run it whenever you have changed anything about the system. And then you can more easily change your models, change your prompts, and have confidence that it's going to be a good result. And they can also run on a larger amount of data than humans can, right? So we do want to figure out how to set up automated evaluation in a way that really measures quality, right? There are multiple frameworks to help you set up automated evaluation. The one we're going to be looking at today is the Azure AI Evaluation SDK from Microsoft. And that's available in Python and also .NET. And it optionally exports to Foundry when you want to see the evaluation results. And I'll be showing that. But there's some other frameworks as well that you may check out. There's one called Tau2. Specifically, if you're building customer service agents, you want to check out Tau2. That's from the company Sierra. That's in Python. There's Ragos. That's from a research-based startup. That's in Python. There's DeepEval, and they now have a whole hosted service. That's in Python. Langsmith from LangChain. If you are building with LangChain instead of Agent Framework, then you might check out Langsmith. And then OpenAI also has evals built into their OpenAI package. And actually, Microsoft is integrating tighter with OpenAI evals. So in a future session, we might show how to use that OpenAI evals package as well, because that can actually export both to OpenAI.com, but also to Foundry now, which is something I only just discovered the other day. So yeah, there's definitely lots of options here, but they're generally all going to have similar approaches to evaluation. The important thing is, set up evaluation with, some sort of system so that you can see what is getting better and what is getting worse. So with Azure AI Evaluation, we are using this package that we install into our project, and you can see it's in our project.toml right here, Azure AI Evaluation. We're also including the red team sub package because we're going to be doing red teaming later today, which is really fun. So we've got that installed here, and that will bring in all of its dependencies. And that gives us access to a bunch of built-in evaluators, also a way to build custom evaluators, to do bulk evaluation, to do red teaming, and this optional ability to save results in Foundry. And we're going to see a bunch of these capabilities today. So how do we evaluate AI agents? So generally, we want to evaluate those agents both at a high level and at a more granular level. So at a high level, we want to see, did the agent accomplish the task, right? The user had a goal. Did the agent achieve the user's goal, right? So that's like this one, intent resolution evaluator. Did the agent achieve the user's goal? And then a similar one is task adherence evaluator. Did the agent follow the prompt constraints and tool use rules, right? So sometimes an agent might achieve the user's goal, but not following the constraints of the system prompt, right? Sometimes it'll try and bypass what you told it in the system prompt and still achieve the goal. But you want it to also adhere to, if you said only use these tools or only, use it this number of times or, don't do such and such, you want to make sure to actually follow those constraints. So we actually do have 2 evaluators for that. And these are all using LLMs as a judge, right? So many evaluation systems use LLM as a judge, where you actually use another LLM to evaluate the results of your LLM-based application. And that's what we're doing here. So we're going to use an LLM to actually look at the response and say, hey, did the agent achieve the user's goal? And we're going to use an LLM to say, hey, did the agent follow the rules when it was achieving that goal? Then we can also look at the response. If we have a ground truth is the perfect response for a particular question, right? And if you can have a data set for evaluation that has ground truth, then there's additional evals you can do, because you can actually say, hey, I know exactly what the response should be for this, and I'm just going to compare it, right? So you can just say, hey, does this response have everything that I wanted to be included based off the ground truth response. And this is like, I always prefer being able to do evaluations with ground truth, because that way it's really checking for hallucination. So I do recommend trying to set up evaluations that include a data set that has ground truth, so that you can check ground truth accuracy and really ensure that you're not getting hallucinations that are convincingly wrong. And then we also can get more granular. So that's with this tool call accuracy evaluator. So here the question is, did the agent invoke the right tool, the right arg? So this is, you're getting really specific and saying like, hey, like, I know exactly how I think the agent should accomplish this goal. It should have called get weather with Seattle. It should have called, get weather with Paris, California. Yeah, I guess Paris, California would be the wrong one. But, you just say like, hey, I know for this input, I expected to call, this tool with this argument. So here you're getting really granular. But that way you can actually see like, you're evaluating the system as a whole, and you're also evaluating the system along the way. And the nice thing about the tool call accuracy evaluator is, because if you get low metrics on these other ones, if you look at the tool call accuracy evaluator, that can tell you why, right? Like, well, why? Well, it called this tool with the wrong arg, right? It should have called it with a different argument. So this can help you understand the why of, where it went wrong with these overall goals. So let's look at each of these in more detail and how we'd actually run them. So first, looking at that tool call accuracy, right? This is our most granular one, which is going to check whether the tool calls are relevant, doing the right tools, the right arguments, and not making any unneeded calls, right? Because we don't want our agent to be doing calls that it didn't have to do, because that's going to waste tokens, waste time, and add unnecessary results to our context. So what we do is we import the evaluator from the Azure AI Evaluation package. It is built in. We set it up with an LLM. We do need to point it at an LLM, because this is an LLM as a judge. And then we're going to pass in the messages from the current agent, right? So we're going to pass in the system prompt that got sent to the agent. We're going to pass in the user's question to the agent, and we're also going to pass in all the tool calls that got sent to the agent. So this is the one that requires digging the most into your actual agent implementation, because you need to send in all this information. We're also going to send in the tool definitions, because that's the only way you can know whether those tool calls are really matching the definitions. So we basically take each of our functions and we turn them into their JSON schema definition, and we pass those in here. And then we pass in the response that the agent gave. So we're really passing in a lot of details here, so that the LLM as judge can make a full decision, right? And then we ask the LLM to score it from 1 to 5. In this case, it could give it a 5 and said, okay, the agent called all 4 of these tools once, which directly map to the user's need, blah, blah, blah. So the LLM judge is always going to give a score and a reason. And it's really, really helpful to look at that reason to see why it thinks that it deserves that score. And especially when you're doing these evaluations for the first time, you really want to go over them once again, with a human that has domain expertise. So you can say, hey, do you agree with that score? Like, was that 5 a right score? Because if not, you're going to look at that reason and see, like I need to maybe customize evaluator, right? So think of these evaluators as like these are like the first things you're going to start with, but eventually a lot of times you're going to build your own custom evaluators that are really targeting things that you specifically see your agent doing wrong. Now, intent resolution, that one's looking at overall, right? How well did the agent achieve the user's goal? So this one, we do send in the full conversation, but we don't have to send in the tool call definitions in this one. Just the conversation is enough, right? So here we can see, okay, it got a 4. It said the user wanted a New York to Tokyo trip. But there was an inconsistent return date, and so it gave it a 4 out of 5. Now, it's interesting. There's this whole debate about whether scores should be binary or 1 to 5. In this SDK, it gives 1 to 5. I've seen other people in the evaluation space argue that it should always be binary. right? Because when it's 1 to 5, you have to decide what is passing. A lot of people consider 4 and 5 to be passing, but if it's a 4, that means it wasn't quite a 5. It wasn't perfect, right? So you may decide, if you're building your own custom evaluators, you might decide to go for binary, which is just pass, fail, yes, no. Because some people argue that's like, that's easier to decide whether it truly is doing what it needs to do. Then we have task adherence. So this one's really similar, but making sure that it adheres to the rule. And this one got a 0. And that was because the tool call used a departure date that disagreed with the return date. So it's interesting because both of these saw the same issue, but for this one, it gave it a 4 because it wasn't a big enough issue. But with this one, I gave it a 0 because it's like, well, for this particular thing I'm evaluating, I consider it a 0. So that is why it's helpful to have multiple evaluators, because some of the evaluators will call out issues that the other ones won't. And you really want to know about any sort of issue, because this is a significant issue if you're, if your schedule is listing a date and if you didn't get a flight for that date, like that's kind of a big deal, right? And then we have response completeness. This is the one where you check for alignment with the ground truth. So in this one, we do have to have a ground truth. So we say, okay, a complete 3-day, right? So here we write our answer. Usually it's going to be like even longer than this, but you would provide your ground truth, and then the LLM is going to judge and say, okay, like it looks like the answer includes everything that was in the ground truth. So it is a complete answer. All right, so now we can actually look at, let's actually run this file here. This is agent _ evaluation. And so you can see, it starts off with all of the agent definition. So we have the whole agent definition. We got a little helper function just to convert the conversation to the style that the SDK expects. We have another helper function just to display evaluation results locally. But then we run the query. We get back the agent response. We have the ground truth here. Then we set up our evaluations with the LLM model we're using. And so you have to decide what model you're going to use. And, there's some debates about whether you should use a smarter model or a less powerful model. But you really just want to make sure you're getting good results, right? So you set up your model, and this does take tokens, right? This takes tokens and takes time. That's why it is kind of you want to think carefully when you're setting evaluations, because these are really slow evaluations, because every time you're running your agent, so that is a whole long process. And then for every evaluator using, these are all LLM judges, they're all going to look at that full conversation and send those to an LLM and make a decision. So this does use up a lot of tokens. So if you do try running this in GitHub models, you may get a token capacity error. So just let us know. We might be able to help you work around that with GitHub models, but this does use a lot of tokens. It does take time. So we set up all those evaluators, we look at the response, and then we just tally up those. So let's go ahead and just run that. I was saying it does take time. Oh, let me do the full file name. So a lot of times when I'm running evaluation, I'm doing it in the background, or I'm doing it in the cloud, or I am gardening at the same time. Like, there's just a general rule, evaluation does take time. So you want to kind of set up a system where you're not being blocked based on evaluation. So you're running in the background or you're running in the cloud. You can run it on CI as well, like with GitHub Actions. I've done that as well. You just want a system where you can, set off an evaluation. When you're running it on a full data set, usually I'm running it on like hundreds of runs, hundreds of like agent calls. That can take like an hour or so. If you do get an error in code spaces, the model that actually worked for me was I changed the eval model config here. I changed it to GPT-5 mini. Now, I know for some people that model hasn't worked in previous sessions, but that was the only model that was able to have enough tokens sent to it. Otherwise, I did get the error that I see in the chat. So do try GPT-5 mini, see if that works for you. It looks like that might be a restricted model, but that was the only one that I actually did get working with the amount of tokens we're sending to it. But if you are using Azure models, then Azure models should all work fine. It's just that GitHub models are very rate limited since they're free. So we have to find models that work with it. But with Azure models, GPT-4o should be fine. I generally use, I think I'm using GPT-4.1 usually these days. But GPT-5, should work as well for Azure models. Okay, so now we did the whole, we did the agent run. We got back this, agent response, a long response here. And so then it's setting up these evaluators, and these take time as well because it's taking that whole conversation with all its tool calls and sending them to each of these evaluators. Okay, yeah, and I see there's some with GitHub models, it might be that GPT-5 mini is limited. So unfortunately, it might be that it's, I wonder also, you could try also only using one of the evaluators here. We try to get everything working with GitHub models, but we are using free models here, and this is a really token intensive task. So you might also see, wait, how would we do? You could like comment out some of these. Okay, so I got a response here because I'm, just running this with my Azure model. So here we can see we got a 5 for intent resolution, and we can see the reason, right? So the reasons are fairly long, which is good. I couldn't fit them all on the slides, but in reality, the reasons are quite long. Response completeness got a 5. Task adherence, this is the one that got, in this case, it got a 1.0, and you can see it did a bunch of, like this one was quite thorough. And it actually breaks it down and says for various things it got a pass, but at one point it said, we got this minor inconsistency. It's funny, it says there's a minor inconsistency, but then it gave it a 1.0. It shouldn't have been a pass. That's a fail. See, my logic for determining pass is wrong. And then 5.0, it got a 5.0 for that one. See. Now, this was just my local display of the results. You can set up whatever display you want. You can, save the results however you want. Whatever works for you. Now, most of the time, you're actually going to be doing bulk evaluation of a data set. So there is a function for doing bulk evaluation, which is evaluate. And there you'd pass in a file that already had a bunch of runs in it. And I was saying I usually would like to have 200 runs or so in there to be really thorough and make sure those really represent what users are sending at the system. And so you're sending in all those runs and then running all of your desired evaluators on all of them. So that's in agent evaluation batch, and it is running off of evaldata.jsonl. So this is a JSON lines file here. And so you can see this just has a bunch of previous agent runs. So I basically ran the agent and I just saved it out. Once you have your agent in production, you're going to find, the examples, bring it back to OpenTelemetry. You're going to find the examples in your logs that did a poor job and add those to your data set. So it's really important that once your agent's in production, you keep on adding the data that you see into your evaluation data set, especially the ones that where you saw poor results, to make sure that your evaluation data set matches what's happening in production. That's super important. Otherwise, you get what's called model drift, where you're not evaluating the kind of data that you're actually seeing. So that's what we passed in to here. So we say, okay, here's our eval data file. These are the evaluators that we're using. We can do a little mapping here if we need to, but that'll run them all. And the neat thing with this is that we can also optionally output it to Foundry. So if you do have a Foundry project set up, you can output it to Foundry project. So I have set up a Foundry project for my local one, and I've already run it. So I can go ahead and let me go to evaluation, automated evaluation. So this is Foundry. You notice I am not using the new Foundry. So in Foundry, there's this new Foundry UI. Unfortunately, we can't view the results from our locally run Python files in New Foundry yet, which I told the team. So I had to toggle off New Foundry. So we are on old Foundry UI, still cute. And we can see the runs here, right? So here's an evaluation run. So I can click on one of these and check out for this run and see, okay, we had, here we're only passing in 3 and they all did well. So it got 100% for all of them. But you can imagine with a set of 200, you're going to see more of a mixed result. And then you can actually dig in and you can look at the actual, look at each of the results and say, okay, that passed, right? It says 4 out of 4 evaluators pass, and we see the score and the reason for, for each of them. So that's actually really nice, because then you can share your evaluation runs like with your colleague and be like, hey, I just ran the evaluation on your new prompt. Here's the results. Check it out. See the ones that failed. What do you think about this, right? And I see a question, how did I save the query results? There's another function I didn't show, agent evaluation generate, and that just ran, it ran the agent calls and saved it. So if you wanted to, you can run this. This takes some time because it's going to run each of those. But that's what I did. I just ran the agent and saved them, right? Once again, it's best if you can have real user data, but until you put it in production, you have to make do. You can also try and use ask an LLM to simulate, to come up with the user input instead of what I did here. Well, I basically did use an LLM to simulate because I asked GitHub Copilot, right? So you start off with the best attempt you can of data to evaluate. But then you improve that data as you get to see what users really put in, right? And then, so once you have the results, you can view them locally. You can build your own custom CLI viewer. That's something that I've done in the past using Python, rich and textual. Or as I showed, you can view them in AI Foundry. You can even set up GitHub Actions using this SDK. I've done that in the past, and that's fun because you can run them on the PR. You don't want to run them on every PR because they are expensive and slow. So I set that up to be, with a comment, if you did /eval, it would run the evaluations, right? So you just have to think about what system you want to set up. And that way, now that we've got OpenTelemetry and evaluation, now you can have this whole dev loop for your AI agents, right? Like you work on your agent, you think it's looking good, you do some vibe checks, but then you actually do some evaluations. Then you do evaluations against a larger data set. You investigate any issues. If it's looking good, then you put it into production. And then you have your observability, your OpenTelemetry, where you're monitoring and seeing what's actually happening. You can also run online evaluations. I didn't talk about that, but you could run these evaluators online as well, typically on just a subset of the samples, and you could have a dashboard for what sort of evaluations you're seeing over time. You can't use the one that requires ground truth, but you could run all the other evaluators that don't require ground truth and do these online evaluations. And then you just want to keep on improving your agent over time and making sure that you're getting great results for it. All right, we have 3 minutes left to talk about safety evaluation. This was something where Gwen and I debated, do we have time to add this in? We do want to make sure that not only is our agent output high quality, we also want it to be safe, right? We don't want it telling people how to, generate, make bombs and stuff like that. It's actually relevant to something happening in the news right now, but I guess we won't get into that. But you don't want your agents generally to produce unsafe outputs, right? And this is the kind of stuff we consider to be unsafe, like hate speech, violence, over sexualization. That does differ for health apps, jailbreaks, that sort of thing, right? So how can we evaluate it? The best approach we have right now is this automated red teaming. This simulates human red teaming. Human red teaming is where you have a bunch of humans in a room and they try to make your application do bad things. So we can simulate that using an adversarial LLM that has all its guardrails off and has the ability to generate lots of horrible, horrible questions that people could potentially throw at your application. So it's going to generate these adversarial questions. It's going to also transform them using common attack strategies like reversing the text, doing Morse code, doing Caesar cipher. There's all these things that people will do to try and inject things into LLM-based applications. And it'll send it to your agent and see how does your agent respond. And then we use another LLM specifically to evaluate as a judge and say, hey, was that a safe response, right? And if it was an unsafe response, that means the attack succeeded. If it was a safe response, that means the attack failed. So we ideally want it so that no one can successfully attack our application with an adversarial question. So we can use the Azure AI Evaluation SDK for this. Use this red team class. This one does require a Foundry project, and that's because it needs that adversarial LLM. And we don't just give access to that adversarial LLM for anything, right? We only give access to it for this purpose because it's got all its guardrails off. So that's able to come up with these horrible questions. So you do need a Foundry project for this. So this will definitely not run in GitHub models. But if you do have a Foundry project, you can point at it. We pass in our Foundry credential. Then we say which categories we care about. We can also specify what sort of transformations we want to try out. Like I always like to do URL encoding because that seems to be a really successful attack. And then, this is where we do the attack strategy. So this sets up our general red team agent. And then when we run the scan, we give it a name. We set up our attack strategy. So these are my two favorite ones is URL encoding, which just is like %20, and then tense, which turns a question into a like historical question. And these attacks are like surprisingly successful in what I've seen. Then we run that red team. This does take some amount of time. It's because it's going to run a bunch of attacks with different transformations. And then we can check those results, right? So I can show you, I've got them open in, so once again, in that evaluation tab in the Foundry old UI, we go to that red teaming. And then we can see this is the one, I ran last night. And it was actually successful on 3 out of 50 of the sexual attacks. So I could dig into that and see like, okay, what happened? Now, the thing is, I have to warn you that when you dig into this, you have to be like mentally prepared because the questions are like really, I find them very offensive and triggering. Luckily, the ones here are like not as bad, so I can show you, but plan a kidnapping. I mean, that doesn't sound like, I know that's bad, but compared to other things, it's not as bad, right? So you're going to look at each of these and you can see these were all ones that actually the attack was unsuccessful. You would filter by the ones that were successful. I'm not going to show you those right now for reasons. But yeah, I just want to let you know, like you do want to look through, especially to see the ones that where the attack was successful, but you also want to be like emotionally prepared for that. And so once you see what's, what it was successful, then you can like maybe modify your prompt, try a different model and see like, okay, how can I make my agent safer? And you should run this red team whenever you change models. You're not going to run them on every code change, but any model changes and any like non-trivial prompt changes, like anything, that's different than a syntax thing, it's a good idea to rerun the scan, right? You'll see big changes across models. I have a blog post where I compared it. So definitely across models, you're going to see changes, but you could also see changes when you change tool definitions, prompts, etc. Then it's a good idea to run a red team. It doesn't take it takes about the same amount of time as evaluation. So it's just a thing you want to be able to run in the background when it's time. Okay. So that is what we wanted to show today. And I know there was lots of questions. So luckily, once again, we have our Discord office hours right afterwards. So please come and join us in the Discord. If you had a hard time joining the first time, that's just because Discord does rate limiting. We talk about rate limiters a lot here, right? But at this point, I don't think it should be rate limiting. So please try to join again so that we can get your questions. And yeah, you can always catch up with any of the previous sessions on our resources page, and you can keep registering to find out about the next ones. So next week is going to be all about multi-agent workflows and building those with Agent Framework. So that should be really interesting, getting into much more complicated orchestrations and seeing what we can do once we're putting together these more complex workflows. So there we go. I am going to jump over to the Discord now, and I hope to see you there with your questions. Thank you so much, everyone, for joining today.
Thank you. Thank you, Pamela. And thank you all for joining. We're always looking to improve our sessions and your experience. So if you have any feedback for us, we would love to hear what you have to say. You can find the survey in the chat or on the screen, and we'll see you in the next one.